Greetings, math fans. All right, so this is day 6 homework, and I'm just going to do every one of the problems. So the first one is page 260, and this is number 23, and that is 2 sine of theta minus 1 equals cosecant of theta. So first of all, you look at this problem and you're like, well, should I square it? Well, squaring actually is not going to do any good because sine and cosecant don't go together, right? Sine and cosine go together, and cosecant and cotangent go together, so squaring it is not going to help at all. So the next thing, kind of look at it is like, well, sine and cosecant are actually reciprocal functions of each other. So what I could do is I could actually change this cosecant into 1 over sine of theta. So I get 2 sine of theta minus 1 equals that. And then why don't I just cross multiply? Now I could multiply all sides by sine, but remember, if you multiply by a variable, you introduce a possible extraneous solution, which means you have to check for those extraneous solutions, see if it is one. Okay, but if I cross multiply, I don't have to. I really didn't do anything to change it. So the kind of nice thing is it's actually the same thing as multiplying it, but if I cross multiply, I get sine of theta times 2 sine of theta minus 1 equals 1. So I get 2 sine squared of theta minus sine of theta equals 1. And then I'm going to move it over because I can see I'm going to factor this. So 2 sine squared of theta minus sine of theta minus 1 equals 0. So if I factor this, I get 2 sine of theta, and this is going to be minus 1 over here and plus 1 over there. Okay? And then I set each of those equal to 0. Of course, this is equal to 0. So sine of theta equals negative 1/2. And sine of theta equals 1. So negative 1/2, right, my reference angle is pi over 6. Oh, they asked degrees, so of course it's going to be 30 degrees. And since it's negative down in these two quadrants here, my answer is going to be 210 degrees and 330 degrees. Okay, and then sine of theta equals 1. That happens at 90 degrees. So there we go. Those are our 3 answers. Okay, next one is 25, and that's tangent of theta minus cotangent of theta equals 0. Okay, so I could move things over and then square both sides. Okay, but again, you're trying different things here, and probably the easiest way to do that, watch this. If I actually change or move this over, right, add cotangent to both sides, and let's change this to 1 over tangent, right? And then when I cross multiply, I get tangent squared of theta equals 1. Take the square root of both sides, I get tangent of theta equals plus or minus 1. That's actually really easy now, right? Because isn't the reference angle going to be 45 degrees? And since it's positive here and negative here, we're just going to go all the different quadrants. So one answer is 45 degrees in the first quadrant, and then 135 in the second, 225 in the third, and 315 in the fourth. And those are your 4 answers. Okay? It's not that bad, right? But again, you kind of have to, it's practice. You know, you try to look at the problem a little bit and see what's the best thing to do. It's kind of like when I have that one problem, remember, sine of theta minus cosine of theta equals 0, right? You move the sine over, or the cosine over, and then you divide by cosine, you get tangent theta equals 1, right? So it just depends. I mean, you know, you could square both sides here, right? But that makes it actually ugly. It works, but it makes it ugly. Okay. 33 is sine of theta plus cosine of theta equals 1. So again, I can square both sides, which is probably what I want to do, but I want to move something over first, right? Just like we did in the notes. If I do 1 minus cosine of theta, that would be much nicer, okay? Because when I square it, I don't get sine cosine together. So I square that and I square that. Again, when you square it, make sure you check for those extraneous solutions. So we get sine squared of theta equals 1 minus 2 cosine of theta plus cosine squared of theta. All right, so then I'm going to change that. Everything's in terms of cosine except for this, so that's 1 minus cosine squared of theta equals 1 minus 2 cosine theta plus cosine squared of theta. And so the 1's cancel, right? If I subtract 1 from all sides, that cancels. And if I subtract cosine, or add cosine squared, I get 2. So you wind up with 0 equals negative 2 cosine of theta plus cosine squared of theta. And just because I like to put it in a nice, this is 2 cosine of theta, right? I like to put it nice format here. 2 cosine squared of theta minus 2 cosine of theta equals 0. So I can factor out a 2 cosine of theta, and I get cosine of theta minus 1. Okay, so let's kind of bring it up over here. I get 2 cosine of theta equals 0. So it really turns out once you divide, you get cosine of theta equals 0, and then cosine of theta equals 1. So where does it equal 0? We're still in degrees here, so 90 degrees and 270. And where does cosine equal to 1? At 0 degrees. Now remember, we squared it, so we got to go plug it back into the original problem. Okay, so if I do sine of 90 plus cosine of 90, and does that equal to 1? Well, sine of 90 is 1, cosine of 90 is 0, so that works. Okay, let's try 270. Sine of 270 plus cosine of 270, does that equal 1? Well, sine of 270, it's down below, so it's negative 1. Cosine of 270 is 0. Well, that doesn't equal 1. Negative 1 does not equal 1. So 270 is gone. And then let's put a 0 in there. Sine of 0 degrees plus cosine of 0 degrees. And does that equal 1? Okay. And so sine of 0 is 0. Cosine of 0 is 1. Yeah. So that one works. So my two answers are 90 and 0 degrees, and not 270. Okay. 34. Secant of theta minus tangent of theta equals 1. Well, that's real similar to that sine of theta plus cosine of theta, right? I'm going to move it over because, again, secant squared is equal to tangent squared plus 1. So if I move this over, I get secant of theta equals tangent of theta plus 1. Then I square both sides, because that's all you can do. So please don't tell me secant of theta is tangent of theta plus 1 and just substitute that in there. It's got to be secant squared. So anyway, you get secant squared of theta. If I FOIL that out, I get tangent squared of theta plus 2 tangent of theta plus 1. Okay, and then secant squared of theta is 1 plus tangent squared of theta. Okay, so the 1's actually cancel, and if I subtract tangent squared of theta, that cancels too. So I wind up getting 2 tangent of theta equals 0. So tangent of theta equals 0. So there are only two places. It's the first quadrant, or first quadrantal, so 0 degrees and 180 degrees. Now I squared the terms, so I got to plug both of those back into the original problem. That's really important. Okay, so if I do secant of 0 minus tangent of 0, that's got to equal 1. Well, secant is the same thing as cosine. Cosine of 0 is 1, so the reciprocal is 1. Tangent of 0 is 0, so it does. 1 equals 1. Let's put a 180 in there. Secant of 180 minus tangent of 180, and that's got to equal 1. Well, cosine of 180, it's on the left side there. That's actually negative 1. And tangent of 180 is back to 0. So that is not equal to 1. So my only answer for this one is 0 degrees. And 180 is out of there. Okay? All right. That's page 260. Now 266. Number 21. Okay, so it's cosine of 2x, and these are all in terms of radians, okay? So cosine of 2x plus cosine of x equals 0. Well, again, this is pretty easy. I think we've done something similar to this, right? You got to change that. You can't have the double angles and all the single angles hanging out together. So we're going to do cosine of 2x is 2 cosine squared of x minus 1 plus cosine of x equals 0. Okay, because you need to have it in terms of all cosines. So if I put it in order to factor it nicely, 2 cosine squared of x plus cosine of x minus 1 equals 0. So if I factor that, I get 2 cosine of x, and then this is going to be minus 1 and plus 1. It's going to work out. So that equals 0. So basically 2 cosine of x minus 1 equals 0. So cosine of x equals negative 1/2, and cosine of x equals negative 1. Okay, cosine is negative in those two quadrants, and the reference angle is, this is going to be in radians, so theta prime is pi over 3. Okay, so that means in the second quadrant it's going to be 2 pi over 3, and in the third quadrant it's going to be 4 pi over 3. Okay, and then where's cosine negative 1? Well, of course it's over here, right? And so that answer is pi. And so those are my answers. Didn't square anything, so those are my 3 answers. Okay, and again, that was problem number, what was that? 21. Good old 21. Okay, next one is 23. And this is in degrees again. So root 2 sine of 3 theta minus 1 equals 0. So we solve for sine of 3 theta. So I add 1 and then divide by 2. So I get 1 sine of 3 theta equals 1 over root 2. So sine of 3 theta equals root 2 over 2. So remember, I'm going to have triple the number of answers. So I get 3 theta. Remember, sine is positive here and here. So 3 theta is, again, this is in back to degrees now. Okay, and it's going to be 45 degrees. Okay, and then 3 theta is equal to 135 degrees. And then you're going to add 360 to each of those. So 3 theta is equal to 405 degrees, and 3 theta is equal to 495 degrees. And you're going to do it one more time because you got to triple the number of answers, right? I'm adding 2 pi to these. And so anyway, or 360, so if I add 360 to this, I get 765 degrees, and 3 theta is equal to 855 degrees. Okay, now you're not done. You got to multiply this by 1/3. Okay, so your answer comes out to be theta. Third of 45 is 15 degrees. A third of 135 is 45, and 135, and then 165, and then 255, and then 285. And remember, math fans, all these values are all between 0 and 360. Okay, and they better be, because that's all the answers are supposed to be between those values. Okay, all right, let's keep going here. A couple more. Number 29 is 2 sine of theta equals 2 cosine of 2 theta. Well, the first thing I can do is I can cancel the 2 out. That's really easy. And then again, you got a double angle here, cosine. So I'm going to do sine of theta, and of course you're going to do it in terms of sine. So it's 1 minus 2 sine squared of theta. Now I'm going to move that over because I want a positive leading coefficient. I'm going to do 2 sine squared of theta plus sine of theta minus 1 equals 0. So if I factor that, I get 2 sine of theta, and this is going to be plus 1 and minus 1. So I wind up getting sine of theta equals 1/2, and sine of theta equals negative 1. Okay, so of course it's signs positive here and here. The reference angle for 1/2 is root, or is pi over 6. Okay, which is, oh, it's 30 degrees. So if they want it in degrees, so 30 degrees. Okay, and so anyway, it's this one is the answer is 30 degrees, and then 150 degrees, 180 minus that, and we're sine -1. We're down here, so that's going to be 270 degrees. Okay, so those are your 3 answers. Didn't square anything, so no extraneous solutions. Okay, 31. Again, this is in degrees, so it's 1 minus sine of theta equals cosine of 2 theta. So again, it's pretty easy. It's straightforward. We're changing that into 1 minus 2 sine squared of theta equals 1 minus sine of theta. Okay, so I'm going to move again this over. If I subtract 1, the 1's cancel, and I wind up getting 2 sine squared of theta minus sine of theta equals 0. Okay, please don't divide by sine of theta. That's really, really bad. You can only factor. Okay, then I factor, and I factor out sine. So I get sine of theta times 2 sine of theta minus 1 equals 0. So I get sine of theta equals 0, and 2 sine of theta minus 1 equals 0. So I get sine of theta equals 1/2. So 2 answers for this guy. So you get theta is equal to 0 degrees and 180 degrees. And this one, of course, we're in these 2 quadrants. The reference angle is 30 degrees. So it's going to be 30 degrees and 150 degrees. Okay, not bad. And last one is number 37. And, ooh, it's a friendly one. 2 cosine squared of 2 theta equals 1 minus cosine of 2 theta. Now here's the deal. This is just like, I mean, you don't want to change this double angle into a single angle, because that's actually brutal, because this is squared. So you're going to have like 1 minus 2 sine squared quantity squared, which is going to give you sine to the 4th. It's very, very ugly. What you need to recognize this as, this is like saying 2x squared equals 1 minus x, right? It's 2 of this term equals 1 minus that term. So that's why it's just a factoring problem. So what I'm going to do is I'm actually going to add or subtract 1 and add cosine of 2 theta. So I wind up getting 2 cosine squared of 2 theta plus cosine of 2 theta minus 1 equals 0. So if I factor that, I get 2 cosine of 2 theta and cosine of 2 theta. And this is going to be plus 1 here and minus 1 here. It should work out nicely for you. Okay, so I get 2 cosine of 2 theta equals 1, and cosine of 2 theta equals -1. And then this I divide by 2, so I get cosine of 2 theta equals 1/2. Okay, and let's cursor down here a little bit. So you got 2 theta, cosine of what is 1/2? What's the reference angle? And this again is degrees. So it's cosine of 60 degrees, right? Is 1/2. So 2, and then we're positive here and here. So it's 2 theta equals 60, and 2 theta is equal to 300. And then remember, they're double the number of answers, so I need to add 2 pi to those, or really 360. So you also get 2 theta is equal to 420, and 2 theta is equal to 660. And then for this one, cosine of 1 is -1. Well, isn't that at pi or 180? So I get 2 theta equals 180. And then if I do coterminal to that, I add 360, I get 2 theta equals 540. Okay, so now the deal is with all these, I need to multiply by 1/2 to get my answers. So I wind up getting 30 degrees, 150 degrees, 210 degrees, 330 degrees, 90 degrees, and 270 degrees. Not in order, but that's okay. Okay, so that's it, math fans. Some are challenging, but it's good practice because the quiz is going to have and the test is going to have all kinds of different problems on it. But these are definitely good practice problems. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.